So, welcome to the live cast of the SpaceX launch of CSG-2. Uh, as you may have guessed from the thumbnail, this is the fifth attempt at doing this rocket launch, so hopefully this will be the one that actually gets to take off. So yeah, one question we might have is why does it take five times to try and get a launch to happen? It might seem a bit odd, but what's happening here is that basically there are many factors that go into getting a rocket launched. So sometimes all these factors are not always ready on the same day. And there's a lot of things that SpaceX can't control, like for instance, the weather or whether there might be some people that are going into the range. And that's what's been happening over the last couple of days. For the first couple of days, the weather wasn't really good at the Cape. Yesterday, the weather was good, but there was a boat that happened to wander into the range. And basically, what that means is that the area where the rocket is flying over is technically restricted. You don't want to have people in there because if there was to be a failure, it could be a risk to the people that are in the zone. So it looked like there was a boat that wasn't aware that they were wandering into a restricted area, and so that ended up canceling the launch. So hopefully the marine traffic is a little bit more friendly today, and we won't have that same issue. Uh, yeah, so let's talk a little bit about the mission and the Falcon 9 and what we're expecting to see today with the launch. And yeah, we'll be waiting for to see when the SpaceX livecast starts up here. Um, yeah, it should be starting up anytime, probably in the next 5 to 10 minutes. So, but yeah, well, in the meantime, let's just talk a little bit about the mission. So, the CSG-2 satellite is a satellite that's built by the Italian Space Agency, and it's basically an Earth observation satellite, which means that it's primarily focused on basically looking at the Earth mainly with photography and with radar and things like this. That data is really useful for places like the military and also in some commercial sectors. So the satellite is going to be kind of a dual use with the military and also the commercial sector. Um, in order to observe the entire Earth, you have to kind of go into a special type of orbit. If you were to go into one that had a low inclination, so you're just kind of going around the center of the Earth, you wouldn't really get a lot of information about the polar regions. So, in order to cover the entire Earth, you typically go into what's called a polar orbit. And that means that you're orbiting with an inclination that's basically going up and down, so north to south. And when you go into this type of orbit, the Earth will rotate around, and basically the track of the orbit will move. It will move with the orbit of the Earth. So essentially, you'll end up covering the entire Earth after a day of orbiting around. And there's one other special type. There's one other special thing about this orbit that it's going into. It's called a sun-synchronous orbit as well. And what this means is that the orbit is timed such that it will appear at the same location on the Earth every single day. So uh, this means that the period, so the time that it takes for the satellite to go around in one orbit, is set up such that you'll be coming over the same spot every single day. And this is interesting because if you want to do comparisons of what's happening on the Earth over time, which is usually a really useful thing that Earth observation satellites do, this allows you to have the same lighting and the same conditions and the same overall uh, variables so that you can make those comparisons with like either some machine learning software or even just with your own eyes. So yeah, this is definitely an interesting mission and one that is, I would say, typical of a Earth observation satellite that would be being launched into orbit. A little bit more about the CSG-2 satellite. It's the second satellite in a constellation of four, so there's going to be four of them. It was originally slated to launch on the Vega rocket, but it got bounced from there because of some delays with coronavirus, and the Vega rocket has suffered a couple of failures, so that was also delaying the project. And so they ended up switching to the Falcon 9 rocket, and that's why we're here today to watch the launch. um, so one interesting thing about the Falcon 9 rocket, of course, is that it's a reusable launcher. At least the lower part of it is reusable. So we're going to see that today. This is a booster called B1052.3, and What do those numbers mean? Uh, the B1052 is the name of the booster itself. Each booster gets numbered starting at 1,000, and then it's been going up since then. So this is the 52nd booster, and the number after the decimal, the point 0.3, is referring to how many flights that booster has gone through. So that means it's been flown twice, and this will be the third mission for that booster. And another interesting thing about this booster is that it actually was a Falcon Heavy side booster. So that means that a couple years ago, it actually flew the mission that it sent the Falcon 9. I think it was for one of the Air Force missions that it flew. And basically, what they have to do there is they have to retrofit the side booster because when you have a side booster, you have to put a nose cone onto it. But of course, you can't have a nose cone when you're using it as just a regular core booster. So they've gone through an extensive retrofit to allow it to switch over from being a side booster to being a main booster. Yeah, so that's kind of the story of the launcher itself. Uh, yeah, let's talk a little bit more about what it takes to reuse the Falcon 9 and what we should be expecting to see throughout the course of the mission. Because there's going to be some key moments to the mission that you should keep an eye out for. Um, so let's talk about the launch and then all the way to the landing. So the first thing to look out for is the actual launch, which will happen at T minus 0. So when the clock comes to 0, you'll see the launch will start. The next thing that'll be interesting to look out for will be MECO, which is standing for main engine cutoff. So that means the big rocket, the rockets will shut off, and then it will separate. The booster will separate, and then the second stage will continue on from there. The booster is going to be able to get all the way back to the launch site because the payload is so light. So what's actually going to happen is it's going to flip around. It's going to do a boost back burn, and then it's going to uh, do a boost back burn, and then it's going to coast for a little bit, and then once it starts getting into the atmosphere and it starts to get really hot, it's going to do what's called a reentry burn, and that's to protect the vehicle from the heating that could come. And then finally, when it gets near to the launch site, it's going to initiate the landing burn, and then it's going to hopefully do a pinpoint landing at landing zone 1, which is the launch pad they have beside the launch site. Because it's on land, we're going to be really lucky because it's a lot easier to get a stable broadcast of the actual landing occurring. So hopefully we get some really nice continuous footage of the booster coming down. This is one thing that's a little bit annoying about when they do the landing at sea, is that because they're on the drone ship and everything's shaking around, they often lose connection at the last minute, and so you you see the booster coming in, and then all of a sudden, oh, it's all pixelated and you don't see anything. But we're not going to have that today. Hopefully, it should be a clear broadcast of the booster coming in and a nice picturesque landing at the landing site. So yeah, definitely looking forward to that. Um, yeah, on the second stage side, of course, once the second stage fires up, it'll continue all the way into orbit, and then once it reaches the target orbit, which is the sun-synchronous orbit, which is at about 600 kilometers of altitude, the engine will of course shut down, and then the payload will be separated from the booster stage, from the second stage of the rocket. One interesting thing about the second stage for the Falcon 9, of course, is one big problem we have in orbit is orbital space junk, and so we don't want to leave anything that's unnecessary up in orbit. And of course, a burnt out second stage of a rocket just sitting in orbit could potentially be a problem in the future. So what SpaceX does is it actually deorbits all of its second stage boosters to make sure that it's not adding to the space junk problem. So this is not something we're going to see in the live cast, but it's something to maybe keep in mind so that you have peace of mind that SpaceX is not trying to contribute more to the space junk problem. Yeah, so yeah, we're going to listen in here. Hopefully the SpaceX live cast will start up soon. And I hope that they're going to be good and live to go for the launch and not going to have any weather problems. Yeah, we'll see how it goes. If you guys have any questions or things like that about the launch, just feel free to type it in the chat and we can definitely talk about them. There's lots of stuff that you might not know, so just feel free to go ahead and ask. But yeah, let's switch over to the SpaceX livecast now. I think they've just started up, so we can turn them on now.
10, 9, 8.
Side booster ignition.
6, 5, 4, 3, 2, 1.
On your screen is a live view of Falcon 9 awaiting its 6:11 p.m. Eastern Time launch from Space Launch Complex 40 at Cape Canaveral Space Force Station. Good evening and welcome to our launch coverage of Cosmos SkyMed 2nd Generation FM2 for our customer Thales Alenia Space. My name is Jessie Anderson, and I'm a production and engineering manager for Falcon here at SpaceX, and I'm joining you today from our SpaceX headquarters in Hawthorne, California. For those of you following along, you'll know that we had to stand down from our initial launch attempts due to unfavorable weather at the launch site. And for our last attempt yesterday, we had to stop the countdown just before T0 due to a ship in the hazard zone. Today, we are happy to report that weather is looking good, as you can see on your screen, and we are currently green on the range. With both the vehicle and satellite healthy, we began prop loading at T-minus 35 minutes. So at the moment, we are looking good for an on-time liftoff today in just about T-minus 11 minutes from now. Now, if you've been following along, you are likely familiar with today's payload, but for those of you who are just joining us for the first time,
All right, so it looks like we are green on all the major important things that could be stopping the launch. So weather's good, range is green, so hopefully this will be the one. Hopefully we won't get any mechanical problems or anything that might come up that might stop the countdown. So this is all good. Good news, good news.
The Cosmos SkyMed 2nd Generation is a constellation of 4 satellites equipped with a synthetic aperture payload able to acquire images in any part of the Earth's surface with an unprecedented resolution and image quality. The Cosmos SkyMed satellites, like the optical systems, are able to operate during the night and in presence of clouds. This is thanks to the specific frequency used for the acquisition. The antenna is totally new and is able to acquire simultaneously images at a very big distance between them, and the data acquired contain a lot of new information with respect to the past generation. For the better use of the satellites and the exploitation of data, we have developed a new control center and processing center in Italy. This will enable the development of new science and new services application for the benefit of citizens, institutions, and entrepreneurs.
Cosmos SkyMed constellation is not only a very important technical instrument in the field of Earth observation, but is also an important support to the strategy of Italy to international collaboration. Thanks to Cosmos SkyMed over the years, and even more will be in the future with the enlargement of the constellation, we can establish collaboration with other countries to share the use of data provided by the constellation and to enlarge the coverage of the planet with other instruments offered by partners. I'm talking about so far, for example, Argentina. We plan in the future to do collaboration with Israel and so on. Also very important is the fact that we use Cosmos SkyMed as third-party contributor to the Copernicus program of the European Space Agency and the European Union. In this way, we offer important strategic and precious data to collect with our constellation, also to other partners, to other producers of data for the benefit of Europe and the rest of the world.
Thales Alenia Space is our customer for tonight's mission, as well as the prime contractor responsible for the entire system. Here are a few words from their CEO, as well as the CEO of Telespazio, which designed and built the critical ground and in-orbit support and operations.
The launch of Cosmos 2nd Generation second satellite
is a cornerstone in the entire Cosmos SkyMed program. The program started in 2007 with the launch of the first satellite of the first generation. Thales Alenia Space is the prime contractor, and we are proud to bring to space a new systems architecture, technologies, and operational capabilities. Full polarization of the sensor enabled to sense the Earth with unprecedented performance. Agility of the platform is really important to add new operational modes, and ultra fine resolution is extremely important to monitor the planet. Cosmos SkyMed is a key program to monitor our planet, to sustain new services and applications, to bring information about the evolution of our planet.
For Cosmos SkyMed second generation, Telespazio provides.
So one thing to note about the CSG mission is that it's actually the second generation of this type of constellation. So there was a first generation, and this second generation is basically an upgrade mainly to the resolution and the sensitivity of the instruments that are on board. So they should be able to get a better, a more detailed look at basically Earth imaging that they want to do. And that will essentially be valuable to the commercial companies that are going to be using that. And I believe also that's necessary for their military contractors as well. So yeah, once they have all 4 satellites up, it's going to be definitely a good upgrade.
We are currently T-minus 6 minutes from liftoff of the Falcon 9 carrying the Cosmos SkyMed satellite, and we're progressing into the final stages of the launch countdown. Now, the 2-stage Falcon 9 vehicle stands 229 feet tall, or slightly taller than a 21-story building.
And you can see here that you have some what looks like smoke coming off both the upper part and the lower part of the rocket. It's not actually smoke; it's actually the liquid oxygen that's inside of the rocket that's coming out. The rocket is fueled by liquid oxygen and RP1, which is a refined kind of kerosene. And in order to have liquid oxygen, you need to cool it down to minus 190 degrees Celsius. And so it's really, really cold. And of course, in Florida, it's a lot warmer. So the liquid oxygen is constantly becoming gas and boiling off, which creates extra pressure. And so you have to relieve that pressure by letting it out of the tank. And that's what generates these vapor clouds that you see here. And basically during the entire propellant loading process, you're going to see those vapor clouds. And it's usually a good indication that the loading of propellant has started.
That is the TE to the left of the vehicle on your screen. Now we use that to roll the vehicle out to the pad and raise it to its vertical launch position. The TE also routes the vehicle's fluids, power, and telemetry umbilicals from the ground systems to the rocket and satellites until Falcon 9 goes on internal power and clears the pad. At liftoff, it will retract in order to clear the way for Falcon 9's ascent. And we're currently waiting for the TE retraction, and in preparation for that, the TE clamps will begin to open, which you should see here. Actually, you can see it on your screen now. Those clamp arms just below the fairing are starting to open up. Once that completes, then the TE can finally retract away from the vehicle.
So she was just talking about the transport erector, which is basically the tower that is basically the ground support for the rocket. It helps to do the fueling, and it also helps to support the rocket as it goes out to the pad. And yeah, it'll start retracting once the launch starts, because you don't want it to be in the way of the rocket bloom. So once it's done with the fueling procedure, you'll see it move back.
Now, at this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Both first stage and second stage should finish prop loading at about a minute apart from each other. First stage should finish up at T-minus 3 minutes, and second stage at T-minus 2 minutes. And you can see some white clouds around Falcon 9.
Stage 1 LOX load is complete.
We heard that call out. Stage 1 LOX load complete. Those white clouds around Falcon 9 is when the liquid oxygen meets the warmer ambient air in Florida there and condenses the air around it, causing those white clouds. At T-minus 60 seconds, Falcon 9 will be in startup. That means that the rocket's autonomous internal flight computers have taken over the launch countdown. Just inside T-minus 2 seconds, we light the Merlin M1D engines for liftoff. The Cosmos SkyMed satellite continues to be healthy, and the Falcon 9 team is tracking no issues on the vehicle. Weather is still looking great, some clear blue skies there over at Cape Canaveral, and the range is green for launch. So with that, we are proceeding into the last few minutes of the terminal count.
So it's really looking great there at the Cape. That's just with the sunset happening and everything. It's definitely very picturesque. So basically, what's going to happen here is the propellant loading is just finishing at T-minus 2 minutes, and now the rocket will be moving into its launch sequence. It goes into like an automatic mode at about T-minus 1 minute, which means that it basically has control of all of its functions autonomously. So the rocket is on its own at that point, and it can start itself. It doesn't need someone to press a big red button or anything. So it's on an automatic timer, and it'll also sometimes stop the launch if there's any issues that it might see, like if there's an overpressurization or if there's an engine that's not quite working properly. It also has the power to do that, of course, much faster than a human could.
The internal flight computer's taking over the launch countdown about 15 seconds or so from now. Once the computers take over, they will execute stored programs and prepare the vehicle for liftoff.
Falcon 9 is in startup.
And great call out there. Falcon 9 is in startup now, just waiting the final call from the launch director here in a few seconds.
Go for launch.
Excellent news here. All systems are go for launch. So let's listen into the terminal count and watch as Falcon 9 transports the Cosmos SkyMed satellite into orbit.
All right, so we officially made it past the furthest point so far. So this is all looking good, and the go no go poll came out with a go. That's what the last call there was when they said go for launch. That means that the humans have decided that the rocket is ready to go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff. In Boca al Lupo. Go Falcon, go Cosmo.
Vehicle is pitching downrange.
This is awesome. This looks so great.
M1D chamber pressures are nominal.
So it's going to be coming up on what's called max Q in a couple of seconds, and what that means is basically that the maximum dynamic pressure will be experienced by the vehicle. So that's the point where it's getting the most drag force from the atmosphere. So that just look out for that. It'll be called out in a couple seconds here.
Still going up, but we're now also heading horizontally away from the launch pad. The rocket typically needs to go
Falcon
about
9 is supersonic.
We need to go about 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth.
Max Q.
And there we heard the call out for max Q. We have now passed through the maximum aerodynamic pressure. This is the largest structure.
So max Q is important because it's basically the period in which the rocket will experience the maximum structural loads. So once you get past that point, you know that the vehicle will probably not experience a failure related to that.
Stage separation, a flip of the first stage, SES-1 or second stage engine start 1.
One thing you'll notice is that the the rocket plume seems to be like expanding as the rocket is going higher up in the atmosphere. You can see here that it's getting bigger and bigger and bigger, kind of like a flower almost. And the reason for that is that the atmospheric pressure at the altitude that they're at now, which is nearly 5,000 meters, or 50 kilometers, sorry, is much, much less. So there's lots of pressure inside of the exhaust that's trying to expand out into the atmospheric pressure. And here we're coming up on MECO.
MECO.
Stage separation confirmed.
And back ignition.
So now you're going to see the core stage. Look at it flip around. And now it's going to light its engine as it tries to fly back. This is incredible. It's awesome that they got the tracking camera on that.
Visually see MECO stage separation and see the first stage flip on your screen. That was incredible to see. Now what you're seeing on your screen on the left-hand side is the first stage, currently in its boost back burn. That is the first of 3 burns to make its way back to land. And on your right-hand screen, we do have the second stage engine lit up, and so far looking really good on a nominal trajectory.
So it's pretty important that when the rocket does that flip maneuver that it does it really fast, because basically if you think about it, the rocket is going the wrong way to get back to the launch pad. So you want to flip it around and stop yourself and come back to the launch site as quickly as possible, because the further you get away, the more fuel you need to make that correction maneuver.
Carrying halves on the second stage being deployed. We've got some awesome views here. The left-hand screen is showing the first stage with the grid fins.
And now you'll see those grid fins slowly extending. And these are basically, they look like kind of like waffle platters. You just saw the nose cone come off on the second stage on the right-hand side of your screen. But yeah, the grid fins are there to provide aerodynamic stability for the core stage as it comes back in for a landing, and it can actually steer the vehicle pretty well with those grid fins. And they're also optimized for like supersonic and transonic type of flight, which is of course what the vehicle is going through right now.
23 seconds into today's mission, and we're currently in the first of 2 planned MVAC burns for satellite deployment. Now at T plus 6 minutes and 11 seconds, you should see on your screen the first stage's entry burn. That entry burn will be the second of 3 burns needed to make its way back to landing zone 1 today. And for the entry burn, we relight 3 of the 9 M1D engines. And that starts with the center E9 engine, followed by the E1 and E5 engines. And that helps to slow the vehicle down as it passes back into the Earth's atmosphere. And we need to slow the vehicle down to reduce...
Both vehicles continue to follow nominal trajectories.
Great call-outs. Everything's looking nominal. And for that entry burn, we do need to slow down the vehicle to reduce the re-entry forces. That helps us to recover and reuse the first stage.
So when the re-entry burn starts, we're probably going to lose the picture for about 5 or 10 seconds. And this is because when the rocket does the re-entry burn and it's coming in, the plume of the exhaust that comes out of the rocket will basically be thrown around the rocket, which creates basically plasma that causes the communications to not be able to go through that. This is just a normal problem, so don't worry. It's not indicating that there's been a failure on the rocket.
Engine on the second stage.
Stage 1 entry burn startup.
We heard the call out, and you could...
So here goes that entry burn. Let's see how this how the connection goes. We might actually get it all the way down. This is actually quite good. Maybe they've upgraded their downlink, because I've never seen it go all the way through like that on the live cast. You can see there's some puffs of smoke coming off the booster on the left side there. Those are basically 2 There's one on the bottom that we can't on the bottom side of the rocket as well, and they're basically little thrusters that fire out nitrogen, uh, basically cold nitrogen, and they cause the vehicle to modify its attitude so that it can pitch into the right configuration when it's higher up in the atmosphere. The grid fins don't work so well with less air, so you have to use the nitrogen thrusters in order to make pitch corrections at that point. And you can see here, you can totally see the cape as it's coming down here. And the landing burn has just started. And seeing it in the IR camera is actually quite cool. This is pretty cool.
Stage 1 landing like deployed. Stage 1 landing confirmed.
Well, it doesn't get much prettier than that. You had not one interruption in the entire landing there. Just perfect picture all the way. So yeah, that's what a typical landing looks like when they come back to the launch site. Definitely a lot cleaner than when they go out to the drone ship.
Speaking of Falcon Heavy, today's flight marks the first time that we have reconfigured a Falcon Heavy side booster to a Falcon 9 mode, which is pretty awesome. Now next up, we will have the shutdown of the MVAC on the second stage. It's coming here in about 10 seconds, and that is called SECO-1, or second stage engine cutoff 1.
So we're just about in orbit here. There you go. That's SECO. That means second engine cutoff. And basically, we should be in a parking orbit at this point. Or not quite in orbit, actually. It's going to light the engine back up again once it gets to the apogee. So that's just the highest point in this arc that it's basically created. And when it gets there, it'll just add a little bit more velocity in order to circularize the orbit.
Around T plus 56 minutes. So we'll see you back here in about 45 minutes. And in the meantime, enjoy the space tunes.
All right, so that was the majority of the mission for the CSG-2. Yeah, it's going to be about 45 minutes before they are ready to go all the way to do the final orbital correction and then release the payload. I don't know if you guys want to stick around until then. Maybe there's some questions you want to have, or we can talk a little bit. But I think we'll probably end the live cast here because there won't be much to look at for the next 45 minutes. And yeah, there's not too much excitement at the end. It's just a couple seconds that the engine will come on, and then they'll let the payload go. But yeah, definitely awesome to see that the mission finally take off. As we stated before, this was the 5th attempt. It's not uncommon that payloads and missions will get delayed, but usually it won't get delayed so frequently. 5 was a little bit more than usual, I would say. Yeah, but great to see that we had a healthy launch. It looks like the payload is going to be deployed successfully, and it's also good to see that we get another booster landing down at the Cape. Just some interesting statistics. It seems to be that the landing of the booster has become way more common than not seeing a booster landing. It was just 2 or 3 years ago that it was crazy to see a booster land, and now it's like we're seeing it all the time. So it's really nice to see that there has been such a rapid technological development on the landing of rockets, and it's great to see SpaceX basically forging forward and developing this technology. Yeah. Of course, they're not stopping with the Falcon 9. They are continuing to develop rockets and expand the realm of reusability. Of course, the Falcon 9 is only reusable with the core stage and the second and the second stage doesn't get reused. It just goes to orbit and then it comes back and burns up in the atmosphere. Um, the Starship is actually going to be able to reuse the entire vehicle, and that's the next rocket that SpaceX is working on. And you probably have heard about it. It's the one that's supposed to go to Mars. Um, so yeah. Yeah, there's maybe some speculation that the reason why we had such a beautiful connection all the way through the mission is that maybe SpaceX has been using their Starlink constellation uh, in order to enhance the live stream experience. I'm not sure if that is actually true, but it could be the case. I definitely do know that the reason why they have trouble getting a clean picture all the way to the ground with the drone ship missions is because the radio receiver on the ship is not stable, basically. So when the rocket is coming back to land on the drone ship, the vibrations from the rocket engine itself are so big that it shakes the ship. And in order to have the satellite uplink working properly, you need to have basically a fixed connection with the satellite. And of course, if the ship's shaking around, it's tough to have that. So that's why they lose connection on the ship. And the reason why you don't have that on land, of course, is because when you're landing, you're probably not shaking the ground. The ground is a little more stable than a drone ship. So I suppose you could probably, figure out a way to keep the you could figure out a way to keep the radio dish like stable, even though the ship's shaking around. But I think SpaceX doesn't really care about having a live link of a landing on the drone ship with perfect video. At least they don't care enough to invest a lot of resources in figuring that out. Um, yeah, they just care about looking at the engineering data afterward, which is of course is all still there. So yeah. Anyways, uh, we should probably definitely cover maybe some more SpaceX missions. We're definitely going to live stream the first launch of the Starship, which is coming up. It's always on the back burner. It seems they've had some troubles with some legal things with respect to getting environmental clearance to launch at their launch site in Texas there. But it looks like over the next month or two, they might be clearing some of that red tape, so we could see a launch um, sometime in probably the early spring. So we'll probably definitely want to be covering that. It's definitely going to be an exciting launch. Um, it'll be basically the first fully reusable vehicle ever attempted or launched. So it'll be interesting to see how that goes. They won't actually be reusing the vehicle though in this test. I don't believe. I think they're just going to ditch everything at sea. But it's just a test. So yeah. Anyways, until next time, thanks for tuning in, and remember to keep expanding your horizons.